Hey, Quentin here. Welcome to the second part of the Self-Inheritance Starter Kit. In this video, we'll cover what the Self-Inheritance Protocol looks like and how we will set up our multi-generational vault. To better understand what the vault setup looks like in the protocol, we'll start by explaining some concepts and tools we'll use to create the vault. Let's get started. If you've already taken custody of your Bitcoin, you probably know about hot and cold storage. But I think it's still worth it to go over the differences between the two and how cold storage allows us to be very, very secure in our wallets. So on the left, we have hot storage, and on the right, we have cold storage. These are very simple diagrams that I use to explain what the differences are between the two. So with hot storage, the signing key is present on the device, which means you can sign transactions directly on your phone or your laptop, but it's less secure because, well, it's connected to a device that is connected to the internet. If we go to cold storage this time, we have a segregation between the environment that is connected to the internet, which is at the bottom, and the environment that is completely protected and secured because it is offline and confidential. So in this case, you have the wallet application on your phone or laptop with the public key, but the signing key is kept offline. That means that if you want to make a transaction, you will need to create the transaction in the wallet and then send it to a hardware wallet or a signing device for the signature and then sending back to the wallet to broadcast the transaction. So it makes things a bit more complex because you have this segregation between online and offline, between public key and signing key, but it makes the whole process much more secure because your signing key stays offline at all times. So this is a security step. It's not something you want to do, for example, if it's a wallet that you use every day for spending. In this case, it would make it very, very difficult to sign the transaction offline every time. So again, the idea is that you can have hot storage wallets with limited amounts present on the wallet, and then you will have cold storage wallets for more secure setups. So that's it for hot versus cold storage. It's good to have that in mind. And now we'll continue with the next diagram. Let's continue with single sig versus multi-sig. With single sig, you have only one signing key, and from this signing key, you derive the public key, and from this public key, you derive the wallet descriptor. Basically, this is done automatically on your phone. If you have a hot storage wallet, you will generate a signing key directly in the app, and it will derive the public key and the wallet descriptor, and it will recreate the interface with all your addresses directly on in the wallet app. If you do single sig with cold storage, you will generate the signing key offline, and then you will export the public key to the wallet app that is on the device that is connected to the internet. And inside the device, it will automatically derive the wallet descriptor and then all the addresses. With multisig, we will create a wallet from different signing keys. And in this case, it's a 3 of 5. So we'll have 5 signing keys. And from these 5 signing keys, we will require 3 of the 5 signing keys to sign the transaction. And this policy is created in the wallet descriptor when you create the wallet. So basically, for each signing key, you will derive a public key, and then we will combine all these public keys with the policy that says 3 of 5, and that will create the multi-signature wallet descriptor. We don't have to go too much into the details. I just want to explain how multi-sig is different from single sig and how it will greatly improve your security. Basically, if someone finds your signing key as a single sig wallet, it's over. You can, they will be able to recreate the public key, and from it the wallet, and from it the addresses with your UTXOs, and they will be able to create transactions and sign them with the signing key. Basically, if they find the signing key, they can sweep the wallet. Whereas with a multi-sig, even if they find 2 out of the 5 keys, they would not be able to spend from the wallet. So it's much more secure. It's a bit more complex, but if you follow the right protocol, it's very easy to implement. So not only is it more secure, it is also something that we can use to engineer a vault and distribute the keys in such a way that we can implement self-inheritance. So by generating a wallet with multiple signing keys, we can distribute the keys in our family and make sure that the heirs have some of the keys so that they can access the vault at some point in the future. So this is it for single sig and multi-sig. We will continue with seeds and passphrase. So this diagram is very simple. The idea is that with one seed, seed A in this example, you will have basically signing key A. Now, if you add a passphrase on top of seed A, you will have a completely different signing key. So basically, what that means is that if you only have a seed, well, you have good entropy, you have a signing key that works. But you can further segregate signing keys by dividing them into a seed and a passphrase, and only by combining the two, you recreate the signing key. And this will be very useful in our vault, because that allows us to separate the elements of the vault in such a way that it creates more security and it prevents collusion from your family members. So this again is a very interesting tool that we'll use in the vault. I'll present how we'll use it later on in the video. So this is how we will create the multi-generational vault. It will be a multi-sig setup with 5 signing keys, where each signing key will be the combination of a seed and the passphrase. So what we'll do is that we'll create 5 signing keys, where each signing key is one seed that is completely different for each, and the passphrase, which is the same for each seed. And what we'll achieve with that is we'll separate the seeds from the passphrase. What that means is that the heirs only have the passphrase. That means that they won't be able to do anything without the seeds. They only have the passphrase. And for the guardians, it will be the same with the seeds. They will only have the seeds and they won't have the passphrase. Remember, if you derive the signing key from the seed, which is basically a signing key in itself, you will get a different signing key than if you apply the passphrase on top of it. That means that for each signing key to be regenerated and sign transactions, the heirs will have to go to the guardians and combine the passphrase and the seeds to recover the signing keys. There is something to keep in mind. The recovery packages will be sealed. That means that the heirs and the guardians won't know what the setup looks like before they open the recovery packages. And the idea is that the recovery packages are yours until you die, and they become property of the heirs. So basically, they won't open the recovery packages before you die. That's the assumption. If they do, well, the guardians have to refuse access to their recovery packages to the heirs. That's how we will engineer self-inheritance. There's always a risk. In this case, the risk is that the whole family colludes to get access to the vault and take the funds out of it. But if there's but if that's a risk, you probably shouldn't be building a multi-generational vault in the first place, and you probably shouldn't be trusting your guardians and your heirs with your signing keys. Now, how can we engineer such a vault? Well, this is where a comprehensive protocol comes in. Let's take a look at another diagram. This diagram I call recovery packages distribution. It's basically how you will create all your recovery packages, how you will distribute them, and what they will include. It's super valuable. You can download it for free below the video. You can use it for your own vault. It's basically everything. So this is how it goes. Each column is a recovery package. You have the owner, you have the heirs, and you have the guardians. Later in the starter kit, we'll see how you can adapt the vault and the recovery packages depending on the number of guardians that you have, the number of heirs that you have. So we'll talk about that later. For now, we'll use a setup where we have 4 guardians and 2 heirs. This will be the basic setup that we use throughout the protocol. It's the one I used for myself. So the owner will have a seed and a copy of the passphrase. The guardians will each have one of the 5 seeds, but they won't have the passphrase. The heirs will have the passphrase, but they won't have the seed. What that means is that the heirs won't be able to recover the vault and to spend from it without going to the guardians and getting access to the seeds. Same thing for the guardians. They won't be able to sign transactions because they don't have access to the passphrase. Only the owner and the heirs have access to the passphrase. Only by combining the passphrase with each seed can you sign transactions. So then, if we go into the details of each element of the recovery packages, I call them envelopes because basically I use colored envelopes to segregate each item of the recovery package. For example, for the seed envelope, you will have a description of the seed, what is a seed, how it is used, what you should do with it, what you shouldn't do with it. You will have a paper backup, you will have a metal backup, and you will have a QR backup if you use a signing device like I do in the protocol. For the passphrase, it will be almost the same. We'll have a description of the passphrase, what is a passphrase, how does it work, how you should use it, how you should not use it, a paper backup, and a metal backup. Then we'll have the wallet descriptor. So a wallet descriptor is basically the sum of all the public keys and the policy for the multi-sig wallet. This is something that you want to back up because to recover the wallet descriptor, you need all the public keys, which means that if you lose a private key and you don't have the wallet descriptor, you won't be able to recover the wallet. So this is very basic. You can print it from your wallet interface. It's very easy. You can have it as a QR code. That means that you can recover the wallet from any device just by scanning the QR code. Now it's only the wallet, right? You have to sign the transactions with the seeds and the passphrase because it is again cold storage. That means that on one side you have the wallet descriptor that gives you the interface with your wallet, And on the other side, the offline side, you have the seeds and the passphrase. So again, you will have a description of the wallet descriptor, what it is, how it is used, what you should do with it, what you should not do with it, and a backup of the descriptor. And then we will have the recovery instructions. This is where you get everything that is useful for your heirs. You will have a description of the recovery instructions. That means what it is composed of, what is included in the envelope. You will have a description of the vault, very, very important. You will have the content of each package. That means that when your heir will have access to their recovery package, they will be able to check what is supposed to be inside the package. Then there will be the package distribution. So this is this document. There will be a flowchart to recover the wallet. There will be a flowchart to explain how to sign a transaction, and you will have 3 guides to explain how to use the wallet, how to recover it, and how to sign a transaction. So this is very, very useful. This is very much needed for your heirs because basically, whether it be single sig, multi-sig, hot storage, cold storage, they will probably not know how it works. So in any case, we have to assume that they don't know and we have to explain everything. And there won't be any urgency, right? They will be able to take the time to study your instructions and understand what you built as the architect of the multi-generational vault, and they will be only the users of the vault. And lastly, a signing device or hardware wallet if you decide to use a hardware wallet. In my case, I decide to use a signing device, and I detail why in the protocol. There is a very specific reason for that. So in my case, I use Seed Signer. So we'll have a description of what is a signing device, how it's meant to be used, and a micro SD card along with a micro USB cable. And that's basically it. The wallet descriptor envelopes and recovery instructions envelopes will be present in each recovery package. And again, the guardians will have the seeds, the heirs will have the passphrase. You, as the owner, have both one copy of the passphrase and a seed, and all the rest. So this is how we will distribute the recovery packages in the self-inheritance protocol. Now that we have a better understanding of how we will build the vault, I would like to present how we will actually do it step by step. So this is the outline of the self-inheritance protocol, and we have 9 sections in this protocol that will guide you through the steps you need to take in order to build the multi-generational vault that we've just described. So section 1 is basically reviewing what we've just discussed with a more in-depth explanation. We'll review cold storage, single signature, multi-signature, signing keys with the seeds and the passphrase. We'll review the vault setup, and we'll see how to adapt the setup to your own situation. So section 1 is basically laying the foundation to understand what we'll do next. Then in section 2, we will prepare the hardware. We have a hardware material list that is the topic of the 3rd video of this starter kit. You'll be able to download the PDF as well and get access to the complete checklist. So this is what we do in section 2. We gather all the material that is needed to build the vault. So in section 3, we will prepare the software. We have a dedicated laptop that we'll use. We have the wallet management interface, which is Sparrow Wallet, and the seed signer for our signing device. And once we have both hardware and software ready, we'll get started with the keys generation. So we'll generate the seeds and then the passphrase, and from there we'll combine them and create the signing keys. that we'll use to create the wallet. Then we'll make backups of these keys. So we'll make backups in the form of paper, in the form of metal backups. This will be the topic of section 5. Once we have the backups ready, we'll generate the wallet. So we'll combine the seeds with the passphrase. We will export the public key of each signing key, generate the wallet, make a backup of the wallet descriptor, add that to everything that we will add to the recovery packages. And then in section 7, we will do test transactions. So we'll receive to the vault and we'll send to the vault as well, just to understand how it works and be completely sure that we can both receive and send from the vault. Then in section 8, we will assemble the recovery packages and distribute them. So that's basically it. In section 9, we'll close the course and talk a little bit about what you should do moving forward with your multi-generational vault. By then, you will have a fully functional multi-generational vault that you can start loading with your Bitcoin. And by then, you will have implemented self-inheritance. You now have the complete picture of what the self-inheritance protocol looks like, how to create and distribute the signing keys, what the recovery packages should include, and how to distribute the recovery packages to your guardians and heirs. In the next video, we'll go over all the material you need in order to create your own multi-generational vault and implement self-inheritance. Don't forget to download the Vault Distribution Diagrams PDF, and if you want to get access to the full self-inheritance protocol, click the button below this video and it will take you to the protocols page. I'll see you in the next video.